Yes, thank you for the introduction. I'm Toshiaki Tsuji from Saitama University. I would like to talk about dual process meta model for robot skill acquisition. And I took PhD in Keio University in 2005 and with the study on motion control. And since then, I have been trying to extend the motion control technology into force sensing, force control, and manipulation techniques. So my future goal is to have a dexterous manipulation technique for the robots. And my future mission is to bridge the motor control techniques with the informatics through the study on the dexterous manipulation, which strongly requires the machine learning techniques. So how can robots acquire dexterity? The key is how the human, we express the dexterity and implement into robots. And in order to do that, there are craftsmanship. For example, we can learn from the craftsmanship that it demands delicate sensory perception and logical judgment. And for the logical judgment, recent generative AI technique is very strong. They can deal with the complicated logics. And therefore, many researchers have been dealing with vision language action model, which is applied in the real environment. But still, I want to claim that the sensory perception is very, very important for such robotics. So, current VLL model inputs the multimodal sensory information directly from the robots. So it is sometimes difficult for the robots to recognize the complicated environment. Therefore, we introduced dual process theory, which is composed of two layers of perception, system 1 perception layer and system 2 cognition layer. And the point here is that this model is well studied in the cognitive science, and the human gathers the information, and in the perception, the environment information is abstracted, and the abstracted information is utilized in the cognition layer, which deals with the more higher layer logics. So, in the same token, the robot is also able to deal with such can introduce such mechanism. So the sensor response should be first input to perceptual process, which abstract the environmental information and utilized for the logical judgment in the VLA. So how to acquire perceptual process? So the very straightforward way is to have handcrafted features. And okay, this is also a good way, but in order to have higher autonomy, it is very important that we eliminate the human intervention from this process. So in such case, autoencoder is a very strong tool in such case. So the high degrees of freedom sensor response are input to the autoencoder neural network mechanism, and the latent variables with lower dimensional information is acquired. And after that, the decoder generates the sensor response with high dimensional information again. So with this kind of a mechanism, the robot is able to reduce the dimension of information from the environment. And since it has lower dimension, these latent variables can be somehow utilized as sub-symbolic variables, which is to recognize the environment and plan for the dexterous manipulation. So this is the challenge of the study. So let me explain in the example with the machine translation. If we input the English characters to this model and extract latent variables, which stands for the meaning of the sentence, then if we input into the Japanese decoder, then the decoder generates a Japanese series of information. So this is how the machine translation works. And if we apply it to robot learning, At first, the human gives the dexterous motion. We detect the position and force of the dexterous motion of human. And after inputting this to the autoencoder mechanism, the decoder in the robot can generate similar motion of the dexterous motion. So this kind of a model can be utilized as an imitation learning model of the robot. And furthermore, okay, this is the example of flipping over pancake motion, which is the typical example of dynamic motion, sometimes difficult, even difficult for human. And we gather the data of position and force from the human flipping over motion and let the robot imitate the motion. And furthermore, if we utilize this latent variable, so this latent variable corresponds to the landing position of the flipping over motion. So if we introduce a latent variable optimizer, then this robot will be able to generate various kinds of flipping over motion without dropping. So with this kind of dual layer structure, it is possible for the robot to adjust the dexterous motion. Okay, this study was done in 2015, from 2015, before the widespread of the generative AI. So this study was the first example of applying language models into robot dynamic motion planning. So we like to emphasize that we are the pioneer of this kind of studies. And this example shows the art grinding of the by the robots. So this demonstration shows that this grinder generates a sketch of the cat, and by learning in different layers, a stroke order and the touch is learned independently in the different dual process layers. And by learning separately, it is possible to generate various kinds of sketches with less number of training data. So this shows that such architecture much improves the data efficiency of machine learning. So this example shows the task of the bottle opening. Bottle opening with 1 millimeter error, as shown in the middle video. The robot will fail opening the bottle. But after learning the failure recovery motion in dual structure layer, the robot is able to generate recovery motion from the failure. So failure recovery motion is accomplished with the dual structure. So why dual process theory? Extraction of subsymbolic variables fundamentally improves data efficiency, model reusability, system scalability instead of end-to-end learning. So I would like to emphasize that the current robotics is well developed, but it is very important to introduce additional layer of perceptual process. So by dexterity acquisition based on such subsymbolic variables, it's able to scale this dexterous manipulation techniques into many tasks like paint removing, assembling, cable wiring. We are also collaborating with some companies with disassembling. So this kind of a technique should be the fundamental of the next generation industrial revolution. So finally, I would like this journey was supported by many people, my supervisors, research collaborators, students, and I would like to also thank with Nagamori Foundation and our committee members and my family. So thank you so much.